The Second World War became a relentless, grinding conflict where logistics proved just as decisive as firepower. The swift advance of Allied forces across Europe in 1944 was constantly threatened by the natural defenses of the continent. Every river, every canal, and every gorge was a potential choke point designed to halt the momentum of the Allied push toward Berlin. German forces, experts in demolition and defensive strategy, systematically destroyed all established infrastructure during their retreat. The sight of a bombed out bridge became a depressingly familiar feature of the European landscape for the advancing American and British troops. The sheer volume of men, material, tanks, and fuel required to maintain the offensive demanded a rapid, robust, and repeatable solution to these vast water obstacles. Traditional pontoon bridges were often too slow to construct, too susceptible to enemy fire, and critically, too weak to support the heaviest tanks and fully loaded supply convoys. The relentless pace of the mechanized army could not be maintained if the engineers had to stop for days to build fixed crossings under continuous bombardment. The engineers faced a nearly impossible dilemma: build quickly, build strong, and do both while under fire from an entrenched and desperate enemy. Speed was paramount, as every hour lost at a river crossing allowed the German defenders to solidify their next line of defense, costing more Allied lives. The solution had to be simple enough for thousands of relatively untrained troops to master, yet strong enough for the 40-ton Sherman tanks. The problem was universal across the Western and Italian fronts, representing one of the greatest logistical challenges of the entire war effort. The Allied war machine risked stalling entirely, drowning in the muddy banks of countless European waterways, all because of the absence of a reliable, fast, heavy-duty bridge. This desperate need created the perfect environment for a radical, unprecedented piece of engineering innovation to emerge from the drawing boards and into the field. The concept of a military bridge needed a complete revolution to overcome the tactical advantage held by the retreating, yet expertly destructive, enemy forces. The stage was set for a seemingly simple invention to change the entire complexion of the European campaign. The fate of the entire operation hinged upon a successful and swift passage over these numerous watery obstructions. The Allied strategy of continuous pressure required a technological leap in mobile infrastructure. A bridge that could be transported easily, assembled quickly, and carry any load was not just a convenience. It was a non-negotiable requirement for victory. Without a breakthrough, the promise of a rapid end to the war would dissolve into a slow, grinding, and costly stalemate along a line of rivers. The pressure on the small, unassuming design team to deliver a miracle of military engineering was immense and growing daily. The genesis of this wartime marvel can be traced directly back to the brilliant mind of a civil engineer and dedicated civil servant named Donald Bailey. Working in the British War Office in the early days of the conflict, Bailey's initial designs were sketched out on the back of an envelope, a classic moment of unassuming genius. His solution was born from the realization that complex military engineering problems required simple, modular, and standardized components. Bailey envisioned a bridge that was not a single, monolithic structure, but a giant, powerful meccano set, easily assembled from interchangeable parts. The core of his design philosophy was complete modularity, meaning any single piece could be replaced and multiple pieces could be combined to create infinite variations. This concept meant that the strength and span of the bridge could be infinitely varied simply by changing the configuration of the basic panels. The main structural component was the bridge panel, a 10-foot-long rectangular steel truss that was light enough to be handled by a small team of men. These panels were held together by precision-engineered steel pins, which were the second key to the design's success, allowing for fast, secure connections. No complex welding or specialized fabrication was required in the field, only human muscle and basic hand tools to lock the structure together. Bailey's design cleverly utilized the concept of launching, where the entire bridge section was assembled on the riverbank and then pushed across the gap using a simple nose section. This eliminated the need for engineers to work directly over the water or under the structure, dramatically speeding up construction time and increasing safety. The components were designed with intentionally loose tolerances, a counterintuitive but brilliant choice that compensated for the inevitable damage and warping in combat conditions. A bent pin or a slightly twisted panel could still be fitted together, ensuring the bridge could always be completed, unlike more delicately engineered structures. The inherent redundancy in the design also meant that if one panel was damaged by shell fire, the entire bridge would not immediately collapse. Sir Donald Bailey, later knighted for his contribution, never boasted about his creation, seeing it simply as an answer to a clear military requirement. His initial prototypes were tested under extreme conditions, proving immediately that the modular concept was not just sound, but revolutionary for field engineering. The final form of the Bailey Bridge was officially adopted by the British Army in 1941, quickly proving its worth in the North African campaign. Its incredible adaptability meant it could span gaps from small creeks to the widest European rivers, serving as temporary or semi-permanent infrastructure. This simple, robust, and flexible design solved the fundamental conflict between speed of construction and load-bearing capacity that plagued earlier military bridges. The brilliance was truly in the combination of standardized parts and the ease of assembly by men who were primarily soldiers, not specialist construction crews. The genius of the Bailey Bridge lay entirely in the standardization and interchangeability of its three main components: the panels, the transoms, and the stringers. The primary load-bearing structure was the panel, a 10-foot steel lattice that could be carried by 6 men, a critical factor for rapid deployment. These panels formed the sides of the bridge, acting as the main trusses, and were the building blocks for the entire structure's strength and length. To increase the bridge's capacity, engineers could stack the panels in parallel, creating double or triple trusses, a key element of its renowned versatility. They could also stack them vertically, creating double or triple story configurations, allowing for staggering strength to carry the heaviest Allied vehicles. The transoms were steel girders that lay across the width of the bridge, connecting the opposing side trusses and distributing the vehicle load. These transoms were precisely spaced and secured to the panels using the ingenious steel pins that were the core of the rapid assembly system. The stringers, or roadway girders, were then laid longitudinally on top of the transoms, forming the base for the wooden or steel deck planks. This layered construction allowed for rapid repairs, as a damaged deck could be quickly pulled up and replaced without disrupting the main structural trusses. The connection between every single component was achieved by simple, heavy-duty steel pins, driven into place with a sledgehammer, a tool available everywhere. The use of pins meant that complex bolting, which required precise alignment and tools, was completely avoided in the stressful field environment. The entire system was designed to function with minimal maintenance and could withstand significant levels of damage from enemy fire. A full 100-foot bridge could be constructed and launched by a trained team of 40 engineers in under 4 hours, an almost unbelievable feat of speed at the time. This speed was a decisive tactical advantage, allowing armored divisions to cross obstacles almost as quickly as they reached them, maintaining the element of surprise. The modular nature also meant that when Allied forces captured a damaged German bridge, they could often use Bailey components to quickly strengthen and repair it. The entire assembly process was a masterpiece of collaborative engineering, where every soldier knew their role in a carefully choreographed construction sequence. The simple, repeating rhythm of panel placement and pin driving became the sound of the Allied advance across Europe. This modular structure proved that a complex result, a high-capacity, long-span bridge, could be achieved through the meticulous combination of simple, easily manufactured parts. As the war progressed and early examples of the Bailey Bridge began appearing in the field, initial German intelligence reports were often met with outright derision by the High Command. The initial view held by many senior German officers was that the Bailey Bridge was a flimsy, makeshift, and unsophisticated structure, a product of rushed, inferior engineering. They were accustomed to their own elaborate, meticulously engineered, and often over-designed temporary bridges, which took considerable time and resources to construct. The lattice-like appearance of the panels and the bolted-together, seemingly lightweight construction were mistakenly interpreted as signs of structural weakness. The name given to the Americans and British for their use of such simple components was often dismissive, sometimes being referred to as a Tinker Toy bridge or toy set engineering. They believed such a crude and simple design could never possibly withstand the weight of heavy Allied armor, predicting that the first Sherman tank to cross would plunge it into the river. This profound underestimation was a direct result of their own cultural bias toward complex, precise, and over-engineered military technology. The German High Command fundamentally failed to grasp the revolutionary efficiency and genius inherent in the bridge's modular simplicity and rapid deployment capabilities. They saw crude field engineering where they should have seen a masterpiece of battlefield logistics designed for the specific demands of a fast-moving war. This technical arrogance blinded them to the tactical advantage the Bailey Bridge immediately conferred upon the Allied armies, a catastrophic intelligence failure. Their destruction of existing bridges was based on the assumption that Allied engineers would be delayed for days, if not weeks, attempting to build a suitable replacement. When reconnaissance photos began returning showing fully loaded convoys crossing major waterways only hours after the bridge was supposedly destroyed, disbelief turned to consternation. The speed with which the Allies could neutralize a river defense, often the only meaningful pause in their relentless advance, began to shatter German defensive planning. The mockery began to fade into frustrated alarm as German officers realized the crucial river lines, meant to be impassable barriers, were being crossed with alarming ease and speed. The psychological impact on the German troops was devastating, as the bridge's rapid construction signaled an overwhelming logistical superiority they could not match. What the German generals had dismissed as a toy soon became the symbol of the relentless, unstoppable momentum of the Allied war machine. The bridge was not just a crossing. It was a psychological weapon that demonstrated the failure of their scorched earth tactics to slow the enemy. While the Bailey Bridge was an inherently British design, its true mass impact on the European theater was solidified by the formidable industrial might of the United States. The American Army Corps of Engineers immediately recognized the bridge's game-changing potential and moved swiftly to adopt the design. The challenge shifted from invention to production, a field where American industry was unmatched globally during the war years. Factories across the United States were quickly converted and dedicated to the high-volume production of the standardized Bailey components. American manufacturing prowess ensured that by 1944, components were being churned out in staggering numbers, solving any potential supply bottleneck. This mass production meant that when the Allied invasion of Normandy began, there was an almost inexhaustible supply of bridge sections waiting to be deployed. The logistics involved were a marvel in themselves, with thousands of tons of steel paneling, pins, and transoms shipped across the Atlantic, often to be assembled within hours of arrival. The American engineers were also masters of efficiency, adapting their own construction techniques to the British design to maximize speed and minimize required manpower. They developed specialized launching equipment and techniques that allowed them to tackle even wider spans than originally envisioned by Donald Bailey. The American ability to organize, train, and equip hundreds of engineer combat battalions was the key to unlocking the full tactical potential of the Bailey Bridge. These engineers, often young men with civilian construction backgrounds, were rapidly trained to become experts in the high-speed assembly and deployment of the modular sections. Their dedication was absolute, as they often worked around the clock, frequently exposed to mortar and artillery fire to complete their vital task. The sight of American GS in their steel helmets, shoulder to shoulder, sledgehammering pins into place under the glare of floodlights, became iconic. Their combined effort transformed the Bailey Bridge from a clever piece of British technology into the backbone of the entire Allied supply chain. The sheer volume of Bailey bridges constructed by the American Corps of Engineers across France, Belgium, and Germany is a staggering testament to their relentless work ethic. It was this relentless combination of British ingenuity and American production capacity that ultimately made the bridge so devastatingly effective. The American ability to deliver not just the components, but also the trained manpower to use them efficiently, was a logistical triumph that historians often overlook. The simplicity of the Bailey Bridge was not just an engineering advantage. It was a training advantage that proved invaluable in the frantic pace of the war. The learning curve for the American and British engineer combat battalions was remarkably steep, allowing new recruits to quickly become proficient bridge builders. Standardized training manuals and prefabricated parts meant that the complex task of bridge construction was reduced to a series of repeatable, easy-to-master steps. The engineers were taught to work as a single, coordinated unit, relying on precise communication and a fixed sequence of assembly to avoid costly errors. Every man had a designated role, from those carrying the heavy panels to those responsible for the final placement and driving of the crucial steel pins. The most critical stage was the launching process, where the entire pre-assembled structure was pushed across the gap using heavy rollers and a temporary launching nose. This nose, made of lighter, expendable parts, would hit the opposite bank first, allowing the main, strong section of the bridge to be rolled into its final, load-bearing position. This launching technique meant that construction time was measured in hours, not the days or weeks required for older, in situ construction methods. In one famous instance during the drive into Germany, a 110-foot Bailey Bridge was fully constructed and opened to traffic in just over 3 hours. This incredible speed often caught the retreating German forces completely by surprise, as their defensive planning had not accounted for such rapid tactical flexibility. The time saved at each river crossing compounded the Allied advantage, transforming what should have been a defensive line into merely a momentary pause. The engineers often worked in the most brutal conditions, including darkness, heavy rain, and, most dangerously, under the constant threat of enemy counter-battery fire. The speed of assembly was a matter of life and death, not just for the engineers themselves, but for the infantry and armor waiting to cross and continue the fight. Their ability to rapidly build a bridge not only saved time, but also minimized the time that large concentrations of troops and vehicles were vulnerable on the riverbanks. The Bailey Bridge was an engineering solution that perfectly aligned with the need for speed, robustness, and ease of use under the immense pressure of frontline combat. The training was so effective that the process became almost automatic, a seamless, well-oiled machine of soldiers transforming steel into a temporary road across water. The Italian campaign provided one of the first and most decisive demonstrations of the Bailey Bridge's tactical supremacy, particularly at the Sangro River. The Sangro River in Italy's central region represented a major defensive line for the German forces in late 1943, a formidable natural barrier in a difficult, mountainous terrain. The Germans had, in typical fashion, meticulously destroyed all the fixed bridges, believing the deep, fast-flowing river would hold the Allied advance indefinitely. The river crossing was critical for the Allied Eighth Army's push toward Rome and the winter line of defenses. The area was heavily mined, covered by dug-in German artillery, and the riverbanks were thick with mud and difficult to approach with heavy equipment. Despite the near-impossible conditions and the fierce opposition, British and Canadian engineers began the audacious task of bridging the Sangro. They had to work under continuous shell fire, with enemy observation posts having a clear view of the entire construction site, adding immense stress to the operation. The engineers, utilizing the modularity of the Bailey design, constructed multiple crossings to handle the simultaneous needs of armor, supply, and infantry. The ability to quickly replace damaged panels and push the structure across the churning water proved invaluable in the face of German efforts to halt construction. The successful crossing of the Sangro was not just a logistical victory. It was a profound psychological blow to the German defenders in the sector. It proved to them that no river, no matter how wide or fast, was an absolute barrier to the relentless Allied advance, shattering their defensive strategies. The Bailey Bridge allowed the Allies to bring the necessary weight of artillery and armor to bear on the German positions on the far bank much sooner than anticipated. This unexpected speed helped to unhinge the German defensive lines, allowing the Eighth Army to gain a critical foothold and continue their grinding advance north. The Sangro crossing became a textbook example of how a piece of military engineering could directly translate into a decisive tactical victory on the battlefield. It underscored the strategic value of the Bailey Bridge as a weapon of war, not merely a piece of construction equipment, by enabling the entire campaign's momentum. The performance of the engineers and the resilience of the Bailey structure immediately elevated its status from a simple piece of kit to an essential component of every military operation. No crossing was more symbolically and strategically important than the assault on the mighty Rhine River, the historical gateway to the German heartland. For centuries, the Rhine had stood as a powerful natural barrier, and the German High Command had absolute confidence that its width would buy them precious time to reorganize. As the Allies approached the Rhine in the spring of 1945, the bridges were, without exception, meticulously destroyed, leaving a vast, imposing gap. However, by this point in the war, the Allies possessed an immense, well-practiced capability to deploy the Bailey Bridge, transforming the challenge into a routine operation. Operation Plunder, the crossing of the Rhine, involved one of the largest concentrations of engineer effort and Bailey Bridge construction in the entire war. At Remagen, the unexpected capture of the Ludendorff Bridge, though short-lived, provided a temporary crossing, but the ultimate, sustained breakthrough relied on the Bailey. Engineers constructed multiple, record-breaking Bailey bridges across the Rhine, some exceeding 1,000 feet in length and requiring specialized construction techniques. These bridges were often double truss, double-story configurations to handle the continuous, heavy flow of all classes of vehicles and armor required for the final push. The speed of construction was phenomenal, with some crossings completed in less than 10 hours, despite the constant threat of aerial attack and long-range German artillery. The sight of these magnificent, temporary steel structures spanning the broad river became the ultimate symbol of the impending defeat for the German forces. For the German High Command, who had mocked the toy bridges months earlier, the sight of entire Allied armies pouring across the Rhine was a bitter, final humiliation. The Rhine crossings confirmed the absolute failure of their defensive strategy to account for such a powerful and flexible logistical counterweapon. The sheer density of the engineered crossings ensured that the advance into the industrial heart of Germany was swift and overwhelming, preventing any effective German consolidation. The success at the Rhine was the ultimate testament to the simplicity, robustness, and manufacturing scale behind the unassuming modular bridge design. It ensured that the final collapse of the Wehrmacht was rapid, as there were no longer any natural boundaries capable of slowing the Allied mechanized juggernaut. The crossing of the Rhine effectively marked the end of Germany's capacity to wage a coordinated defensive war in the West. The true secret weapon of the Bailey Bridge was its unparalleled versatility, allowing engineers to adapt it to almost any situation encountered in the field. The basic 10-foot panel could be combined in literally hundreds of configurations to meet a diverse and ever-changing set of military requirements. When a standard bridge was not strong enough for the heaviest tanks, engineers simply connected a second row of panels in parallel, creating a double-truss bridge. For exceptional strength required by railway traffic or specialized heavy equipment, they could combine 3 rows in parallel, resulting in a triple truss structure. If the span was too great for a single launch, the bridge could be built with temporary intermediate supports in the river, resting on caissons or pilings. The system was also used to create floating pontoon bridges by placing the components on a continuous line of pontoons or barges to span even wider, deeper waterways. Furthermore, the components were frequently used not only to span gaps, but also to reinforce existing, damaged bridges that were otherwise structurally unsound. The modular panels were often repurposed as temporary jetties and piers for offloading supplies from ships onto beachheads or riverbanks where harbors had been destroyed. They were even employed as temporary supports for heavy lifting equipment or as components in the construction of temporary runways and hard standings for aircraft. The bridge panels, being standardized, could be taken apart at one location and immediately reused at a completely new crossing further down the line of advance. This ability to recycle and reconfigure the structure added an incredible layer of logistical efficiency that no other military engineering equipment could match. The continuous innovation in the field, with engineers constantly finding new ways to exploit the modularity, speaks volumes about the design's underlying genius. No other single piece of equipment offered such a wide range of solutions to the various problems faced by engineers in a dynamic, high-pressure combat environment. This inherent flexibility ensured that the Bailey Bridge remained the indispensable go-to solution for almost every crossing requirement until the final days of the war. Among the many military leaders who came to rely on the Bailey Bridge, Field Marshal Bernard Montgomery offered one of the most famous and unequivocal endorsements. Montgomery, the meticulous and often demanding commander of the British and Commonwealth forces, understood logistics as well as tactics. He recognized that the ability to cross water obstacles at will was the ultimate key to maintaining the relentless momentum of the Allied campaigns. His famous quote cemented the bridge's place in the history of the war. The Bailey Bridge made an indispensable contribution to the successful conclusion of the campaign in Northwest Europe. He continued by noting, "Without the Bailey Bridge, it would have been impossible for us to maintain the speed of our advance." This praise from one of the war's most critical and high-ranking generals was a profound statement on the bridge's strategic significance. It validated the simple, elegant design as one of the most important pieces of military equipment produced by the Allies during the entire conflict. Montgomery's assessment highlighted the fact that the bridge was not just a convenience, but a fundamental enabler of his most successful operational strategies. The ability to plan rapid advances without fear of being permanently halted by a destroyed river crossing completely altered his tactical playbook. General Dwight D. Eisenhower, the Supreme Allied Commander, offered similar praise, declaring the Bailey Bridge to be one of the three most important pieces of Allied military equipment. The bridge was often ranked alongside the Jeep and the Douglas C-47 transport plane in its overall contribution to the Allied victory, illustrating its pervasive impact. The recognition from these senior commanders was a direct repudiation of the initial scorn and mockery from the German High Command, who had underestimated its potential. Their public and private praise acknowledged the sacrifices of the engineers and the brilliance of Sir Donald Bailey's design. The consensus at the highest levels of Allied command was clear. The Bailey Bridge did not just help win battles. It accelerated the timeline for the war's conclusion. These formal and informal tributes remain a permanent record of the bridge's immense and essential role in the eventual Allied triumph in Europe. The immediate post-war legacy of the Bailey Bridge proved to be just as profound and enduring as its impact on the battlefield. With Europe's fixed infrastructure lying in ruins, the modular Bailey components became the perfect temporary and often semi-permanent solution for rebuilding transportation networks. The bridge literally became the backbone of civil reconstruction, allowing essential supplies, food, and building materials to flow into shattered cities and towns. Thousands of Bailey bridges that were erected for military purposes were simply converted for civilian use, serving as vital crossings for years, sometimes decades. The design was so robust and effective that it was adopted by civil engineering agencies worldwide for emergency repairs following natural disasters. It remains, even today, one of the most widely used and recognizable temporary bridging solutions for relief efforts after earthquakes and floods across the globe. Its utility was not confined to Europe. It played a significant role in reconstruction and development projects in Africa, Asia, and the Americas for decades after the conflict. The design principles, modularity, standardization, and ease of assembly set new standards for temporary military and civil engineering worldwide. Sir Donald Bailey never received substantial financial reward for his invention, but his knighthood and the bridge's universal adoption stand as a greater testament to his achievement. The German High Command's initial mockery was entirely forgotten, replaced by the universal recognition of the bridge's revolutionary design and its undeniable success. The bridge components are still manufactured today, a rare distinction for a piece of military technology designed and deployed 80 years ago. It is a silent, steel monument to the fact that elegant simplicity often proves superior to over-engineered complexity, especially under the chaotic conditions of war. The bridge saved countless lives, both by enabling rapid medical evacuation and by accelerating the end of the conflict itself, minimizing the overall death toll. It stands as a powerful symbol of Allied logistical superiority and a triumph of practical, problem-solving engineering over rigid, traditional thinking. The bridge taught the world a valuable lesson about the power of standardization and the beauty of a design that is robust, flexible, and utterly functional in its purpose. The story of the Bailey Bridge is ultimately more than a tale of steel and rivets. It is a profound lesson in the strategic power of engineering ingenuity. The bridge's success was a decisive victory for the idea that a simple, universal solution could overcome complex, disparate problems across an entire continent. It transformed the war from a static, defensive campaign along river lines into a dynamic, relentless pursuit that the German forces could not halt. The engineers who built these bridges were the unsung heroes, often working in the most exposed and dangerous positions to keep the Allied advance moving forward. Their dedication under fire, coupled with the genius of Bailey's design, forms one of the most compelling narratives of technical excellence in military history. The bridge stands as a perpetual reminder that logistical capability is the lifeblood of modern warfare and often the true arbiter of success on the battlefield. It proved that the ability to quickly deploy and redeploy infrastructure is just as important as the ability to field tanks and aircraft. The principles embedded in the Bailey Bridge continue to influence contemporary engineering design, from rapid housing construction to modular manufacturing. Its lasting presence in post-war reconstruction and disaster relief efforts demonstrates its timeless utility beyond the immediate context of military conflict. The bridge is a powerful historical artifact that embodies the spirit of collaboration between British innovation and American industrial capacity. It remains a potent symbol of the immense technical and organizational superiority that the Allied nations brought to bear against their Axis opponents. The German High Command's initial laughter was silenced by the roar of thousands of Allied tanks and trucks crossing the rivers they thought were secure. Every river that was crossed, every defensive line that was breached, and every day the war was shortened stands as a testament to the Bailey Bridge. It is a masterpiece of functional design, a humble piece of steel that truly bridged the gap between a challenging war and a swift victory.